Hello everybody. It's difficult to know where to start, so I think I should start by introducing the gentleman behind the camera who you will not see, but he's Dave Knott, and I've known Dave since 1984 when he was introduced to me by Ron Hodkinson, who I've also known for the same amount of time. The purpose of this video is to explain to you the slideshow that is going to be following the video. There's a saying in this world that be careful for what you wish for, you might just get it. Now, right across the planet and down to earth through the United Nations and through the churches of any creed or colour, etc., everybody is wishing for clean drinking water for the world's populace. And with clean drinking water comes clean water for irrigation and sanitation. That's what they're wishing for. And we in the Western world are wishing for a clean energy solution. The nuclear lobby is writ large, and so is the fusion lobby, the biological lobby, the wind turbine lobby. The green people are all out there wishing for something. Now, if circumstances allowed these wishes to come true, would we not have the key to Pandora's box? A mythical box where everything that we wished for and desired was locked up in a box until one day somebody found the key and rashly opened the box to let free everything that we wished for and desired, to make havoc amongst mankind when hope only remained. The hope is that we have the culture, the ability and the intellect to cope with unlimited fresh water, unlimited green energy. Well, my friends, bypassing the United Nations and all the politics involved, I'm going to introduce you to the key to Pandora's box. You can take the slideshow and through modern technology pause on each of the pages and digest what it says. So we've recently had a debate in the UK, and the politicians have been involved, on whether or not a takeover from an American company to a British company in the drug business should take place at £56 billion plus. The figure doesn't really matter. The question asked to you: if a company has X number of patents in the pipeline and expects to make huge amounts of money from those patents, where do I, as a humble servant on this planet with a key to Pandora's box, stand with my two patent applications? One is for a very simple device, and it's all in the slideshow. It just simply takes a superconductive rotor with X number of poles that rotates at 0 to 10,000 RPM, the figure doesn't really matter, and passes through, you guessed it, a superconductive stator or coil, and as it passes through it generates an EMF, an electromagnetic force, within the coils of wire. But then of course it does something quite silly. It goes back to Faraday. It passes right through the coil and out the other side. This means that the laws of inductance will come into play and the field will collapse, producing a very high voltage spike. Now, if high voltage on two hollow electrodes equals a potential, the potential difference is the air to start with, which is seen as a resistance. This resistance will automatically drop the voltage and start drawing whatever current the superconductive stator is capable of producing. So, it naturally follows that if we inject simultaneously water from the left to the right and water from the right to the left, it's going to meet in the middle and create a short circuit. But the amount of current flowing through the water will instantaneously explode it into a burning gas of hydrogen oxidized by ozone. In simple terms, viewers, what I have done is created a lightning discharge in miniature within the laboratory or between my two hollow electrodes. So what have we done? Energy in is energy out, less losses. How much energy is required to spin the superconductive rotor? How much energy is required to push it through the superconductive stator? Once we've established those figures, we can work out how efficient exploding water is in comparison to a slow process of electrolysis, which we all know you put a third more energy in to get the same amount of energy out, i.e. you've lost a third. My system states that if you get your figures right, you will in point of fact break more or less even, but your fuel is water. Now if you burn water, or explode water, it's going to condense into fresh water. So it logically suggested that if you had a ship where you pump the ballast water all over it to stabilize it, and you have microns, or we will call them larvae, we will call them plankton, that you don't want to transfer from sea to sea, well, why not just simply pump your ballast water through my electrodes, take out the energy in the form of hydrogen and ozone, which basically, when you put the two together, is burning as if it was combusted rocket fuel, and then recondense it. You have now you have solved the global problem of pollution of ballast water. I now want to pass on from this patent, which I've just outlined to you, to another patent called the RAM Vortex Compressor. The one I have just described is called the RAM Vortex Combustor. It doesn't take rocket science to understand that the three initials RVC are, of course, the initials of my name, Richard Vere Compton. May God have mercy on my soul, but I digress. So the RAM Vortex Combustor will take the energy released from the water and use old-fashioned steam technology in a different fashion. So let us imagine we've got a Pacific steam locomotive and we're going to build our kit inside the firebox, but we're not going to burn a fossil fuel, we're not going to have hot burning coals, and we're not going to have any sulfur pollution or particulate pollution. So the question is, if we want to put our steam units back on the permanent way, and you've got concrete sleepers, they're not going to like the retinous thud or the sonic vibration that you get from the throw of the crank between the driving wheels. So consequently, we cannot use a piston in the conventional form. So what we have to do is to look at some form of turbine. But we cannot use a conventional turbine because of the amount of steam required to make the turbine work. So once again, the outside the box or unclean sheet of paper has brought me to Archimedes of way back in Greek mythology or Greek reality, depending on which side of the coin you prepare to look at, or a friend of his who came a little later on called Hero of Alexander, who invented the steam kettle. This was nothing more than a cauldron from, shall we say, Macbeth, boil and boil, toil and trouble, but I digress. The water was heated with charcoal, it boiled quite vigorously. Hero of Alexander took what he had available, made some copper tubes as uprights, made a crude rotating joint, rather like a spit, was able to get some of the steam into the sphere, and by fixing tangential jets in a crude swastika round the sphere, was able to rotate the sphere, and as the sphere rotated, it turned a whole carcass of meat over afar. The next question is that Hero of Alexander looked at Archimedes' hydraulic lift screw and was able to put his device on the end of it, and he could then lift water to where it had to go, into an aqueduct or into a feed trough for bathing arrangements. All this, we'll say, was circa 10 AD. So what has yours truly come up with? Exactly the same system. but this time I'm using an Archimedes self-returning ball screw, which means that on one shaft I can cut two sets of tracks which will bring two pistons towards each other on the same rotating shaft. But as the name suggests, the Archimedes self-returning ball screw, that when the two pistons have nearly kissed each other, they automatically follow the thread back to repeat the process. If we now turn those two pistons literally into pistons, and we put some slots in them so that we can inject steam simultaneously from the far left of the piston, which we will call the maximum compression, and the far right, which we will call the maximum compression of the other piston. The pistons, although they are already rotating, because I will come to that in a minute, will be driven down the Archimedes self-returning ball screw, imparting the power of the steam. But as we all know from steam technology, steam only works best when it expands. So here we go to a modern version of Hero of Alexander's steam turbine. This time we've built a pancake cylinder. So we've taken, in theory, the cube block of a Pacific locomotive with its big piston and its feed valve piston, and we've looked at the size of that. We've stood it up through 90 degrees so it's vertical, and we've changed the configuration so that it is a pancake shape, and instead of having a couple of drain cocks, we have X number of tangential jets. You can see what's going to happen. The steam enters from the left and from the right and pushes the piston. The piston adds further inertia to the already rotating shaft, and as it does so, the piston enters what we will call the expansion chamber inside the Hero of Alexander's turbine. The steam then expands rapidly and is forced out through the tangential jets. Now, what is the raison d'etre for doing all this? It's very simple. That a brief was given to the Rail Transport Laboratory and through another agency to find out if it was possible to put batteries onto trains and remove the diesel driving units. And they came up with the solution, or the answer to the problem through their consultancy, that as diesel in this country we'll call red diesel is at 40p a litre, it would have to climb to 80p a litre before you could even consider it. But they carried on with their brief and said, well, possibly we could use a scissor lift to swap out 1 tonne of batteries and put in another set of batteries, drop and swap. But really, they came to the conclusion, we're stuck with a good old diesel engine for what seems like a very long time and all the CO2 it produces. As I was not governed by the same restraints as the consultancy company through the Rail Transport Laboratory, I took a sheet of A4 paper and said, hang on a second, why don't we go back to just 1935, when Dave Knott reliably informed me through textbooks and through published works that between 1935 and 1945, when ammunitions were being made, it wasn't really the right thing to do to have sparks flying around everywhere. So steam would be made off-site and then transferred to a steam locomotive, which would basically be a thermos flask on wheels. And the steam would last as long as the duty cycle, or it'd go back and pick up some more steam. So my solution to making the whole of the world's railways green is to use my first patent for the RAM Vortex Combustor in conjunction with my second patent application for the RAM Vortex Compressor, and this time the fully charged batteries and my full thermos flask of steam. The train leaves the depot with its fully charged batteries driving electric motors, which take it to the terminus station, where it can sit on a third rail or pick up energy from an overhead pantograph, but only for the length of the station platform. Once it clears this, the battery power alone will drive the locomotive up to what we will call 65 miles an hour with the acceleration that electric motors give you in order to get as many trains as possible on any given section of track. Now remember, the shaft with the Archimedes self-returning ball screw on it and its pistons is already rotating. Now, because it's rotating, the chunk of metal, which we're going to call the pancake the pancake Hero of Alexander's turbine with its tangential jets is also rotating. So we have to overcome the load that the chunk of metal will take up on the shaft, but once we've overcome that parasitical load, we actually have a flywheel on the main drive shaft. Now, of course, the drive shaft has to go through a hydrodynamic drivetrain to the wheels. So the scenario is very simple. The train leaves the station, the Hero of Alexander's tangential turbine is whizzing round, it reaches 65 miles an hour, we then inject our steam into the back of our two pistons, the pistons are pushed along the Archimedes self-returning ball screw, they enter the Hero of Alexander's tangential jet expansion chamber and the steam passes by. Now the interesting thing is that as the pistons go back into their into the cylinders, they close off the steam so it can carry on expanding, but this time they meet the residue of the steam that's pushed them in the first place. This time they are compressing the steam and any water vapour that might have occurred in the short state of this cycle. Now, we all know that you cannot compress water, but the beauty of this is we now build another set of Hero of Alexander's turbines, literally on the far left and the far right. This means that as the piston comes back, it can push the steam and some of the condensate into the left and right secondary turbines, with the result is that these turbines are now not fixed to the shaft, but fixed to an independent drive, which can put energy back into the batteries or whatever method we want to use. In a nutshell, viewers, I have given you the answer to what the chief executive of the Santa Fe and Union Pacific Railway said in an article in Time magazine. Can someone tell me why hydrogen, the most prevalent material, substance, gas, liquid, whatever you like to call it, on the planet, is so difficult and therefore so expensive to get at? Within this sideshow and within the dissertation of this video clip, I have told you how it can be done. It is now up to you and the universities to look very, very carefully at what I have said. Now, you might well say to yourself when you close this video down that if you're one step ahead of your crowd, you are a genius. But if you're 2 steps ahead of the crowd, you're a crackpot. It has been said to me, to my face, Richard Vere Compton, Richard, you are not just 2 steps ahead of the crowd, you're off the planet. And on that note, I will finish. Thank you very much indeed for watching.